All right. Hello. I'm going to give you a very brief overview by slides of a new forest carbon knowledge and learning management platform that the MSU team has developed in collaboration with some Indian partners. This was done to support a number of USAID projects, and we believe that we can expand its application to many other countries worldwide. So who is the group? First of all, we're the Global Observatory for Ecosystem Services at Michigan State University. This is my group, David Skoll. And secondly, we're partnering with the IORA Ecological Solutions Group in Delhi, New Delhi, India, which is a private company. It is a for-profit company, but it is one of those social entrepreneur companies that is trying to do well by doing good. We've had these platforms deployed in India, Indonesia, and Malawi as test beds, and we work as a group in those countries as well as several other countries, including Brazil, Costa Rica, Senegal, Kenya, Malaysia, and Vietnam, very actively right now. Funding for the development of this work and some of our other kind of research and development activities related to climate change mitigation tools and knowledge management platforms have come from USAID, NASA, the California Governor's Climate and Forest Fund, which is the program that supports international aspects of their emissions reduction program in the state of California, the GEF, and the World Bank. The focus of this tool building and applications is on RED Plus, on capacity building in countries that are developing their RED programming, and for the MRV development in countries that are developing RED capacity. MRV is measurement, reporting, and verification. The focal point for this has been leveraged from our program at MSU called Carbon to Markets and the Carbon to Markets model. There's the link to that. You can check it out. We'll only have a few words about that a little bit later. And we are very much using the technologies of Earth observation, satellite remote sensing, both in the commercial sector and in the public domain sector, cloud-based web applications, learning management tools, capacity building models and activities that we have, as well as specific tools and methods for outreach and communications. The idea is to use the technology to cover extremely large areas of land using cloud-based applications and learning management systems and capacity in a program that has very much outreach and communications to reach millions of people. Millions of hectares, millions of people. The origin of this activity has been focused on the carbon to markets model. The carbon to markets model is something we've developed a long time as a on-the-ground approach as well as a technology approach to addressing two of the grand challenges that the world's facing today through one intervention. The two grand challenges, of course, are climate change on the one hand and rural poverty on the other. And what we are doing is developing a model that combines commodity value chains with carbon value chains, hence the term carbon numeral 2 markets. We focus a lot on agroforestry and systems of trees outside of forests, plus the forest estate in developing countries under the RED Plus. Piloting this model in Thailand through the Impang network with a focus on teak forest plantations for smallholders, we were able to sell credits on the Chicago Climate Exchange to testbed this approach. The lesson that we got from that was that to participate in the international arena, countries and communities in the developing countries need measurements, human and technical capacity. They need the tools to do the measurements and participate in climate mitigation, and measurements to support poverty alleviation, and a strong component of community engagement. Our work has been focused here in the Carbon to Markets model development programming at the community to subnational to national scales. We think that this is going to be important with the failure of the U.S. to participate in the international agreements. There will be a strong look towards subnational entities like California, and there'll be a strong look in REDD Plus and other programs to link climate mitigation and rural development at the community scale. A number of our partners in India and Malawi work directly with community-based carbon measurement, and we work with joint forest management or community co-development or co-management of forest resources. Okay, the focus then for the work has been on something we call actionable science. This is not pure or basic science. This is taking the best methods, the best tools, and the best know-how from years and years of carbon cycle research, basic fundamental science research, the kind of research that's underpinning the Intergovernmental Panel on Climate Change work and some of the basic climate science work, but we're taking it out into the communities and applying it. So we're working with countries and communities that really don't need science tools per se. What they need is specific applications based on science methods. Some people call this user-inspired science or translational science, and we really refer to it as actionable science. So it's boots on the ground applications of the best science that we have, but we're not doing basic science. We're really applying the methods and the results from many, many years of work in the science community. We're really working on specific capacities for REDD Plus and carbon management on the land, enabling participation and compliance post-Paris agreements by developing countries. And in that context, you really have this requirement set out by the international community to develop in any country 5 key components of their REDD strategy or REDD programming. First is the national REDD strategy. The second and really core piece is the development of the National Forest Monitoring System, which I'll talk about in a minute. This is really core to what we're doing. Developing reference emission levels, developing the safeguard information systems for biodiversity and communities and livelihood safeguards, developing then finally a national reporting structure. So in essence, of the 5 basic required components for a country in developing REDD programs, 4 are seriously nested in having tools to do the detailed technical measurements that are required. So the National Forest Monitoring System is a key and core element of any country's or any subnational entity like a state or province's participation in the post-Paris agreements. The first piece of this is the National Forest Inventory, or the NFI, which is a system of field sample plots that are systematically and statistically defined by number and location. And there in these plots is where measurements are made of the forest on the ground to compute emission factors. This is where also the allometry for carbon comes in, the allometric equations that define the translation of a parameter of the forest or tree structure, such as the diameter of the stem, into carbon stocks for the site. So there are very specific protocols and methods for measuring carbon on the ground, and we're developing the tools as well as the protocols and the allometric libraries that provide cloud-based online support for organizing all the inventories, computing the number and locations of inventories in order to meet statistical requirements, and then producing calculations that produce the carbon stocks or the emission factors through a online shareable library of allometric equations and a support tool that allows you to develop your own allometric equations. The second key piece is what's called the satellite forest cover monitoring component, or sometimes called the Satellite Land Cover Monitoring System, or SLMS. This part of the National Forest Monitoring System is the piece that uses the remote sensing to measure and map deforestation and degradation. Yes, including degradation, in order to be compliant with RED. It also provides a means for using remote sensing to extrapolate the ground measurements into maps of forest carbon. This area is often referred to as developing activity data. We've developed a data management system that couples directly with the plot inventory system that allows us to do this very thing. It acquires satellite data. We have the tools and the methods for calculating deforestation and degradation rates, for mapping the deforestation and degradation rates, and even mapping the intensity of degradation across the landscape. So by combining the satellite activity data and the ground-based emission factors, we have the elements that are necessary to compute emissions and removals. And this is then all pulled together in a greenhouse gas inventory and reporting piece of the National Forest Monitoring System. This is the essential piece that's required of all countries to develop their reports, in particular the reports called the NDCs, the Nationally Determined Contribution Reports, and it needs to use standard IPCC methods and tables, and contain all the tools for computation and data management. We have the protocols, we've developed the protocols, tested the protocols for doing the reporting and the measurements, and this relies very heavily on our platform to do that. So to deliver on these needs, this actionable science for MRV, we've developed 3 integrated platforms for forest carbon measurement and management. The first is a knowledge management platform that includes new remote sensing protocols and methods for mapping activity data. It includes a forest data management system that allows the user or the agency to develop its emission factors from a national forest inventory of plots, and to design the sample frame necessary for the national forest inventory. And then we also have developed a handheld field application that goes on smartphones so that it supports the needs of data collectors in the field to collect carbon measurements. And through the cell phone system of a country, it's tied directly back to the cloud-based server, wherever it might be located, and uploads the data in real time as the measurements are being made. This allows for instantaneous computation of data while in the field in order to make necessary adjustments, to fix errors, and to do a QA before teams leave the field, which can save literally thousands and thousands of dollars and hours of time in doing so. The second piece is a learning management platform. This is essential in having a capacity building component that goes along with the technical tools. It allows for training in the basic concepts of climate change mitigation, carbon cycle science, as well as the rules, the protocols, the methods for doing field measurements and calculating emissions and removals. And we've developed a online tool, this LMS, with a curriculum that's in place that can be taken right off the shelf, or can be adjusted according to local needs of the training institution or the agency or the community. So it includes a course curriculum for MRV, and also a flexible learning management system, or LMS, built around the publicly available Moodle environment using the Moodle language, although with our own structure assigned to it, that allows the learning provider to customize and tailor the curriculum and the course information to what the learners want. Incidentally, it includes a knowledge management platform, or this forest data management system, embedded as a living laboratory, so learners can practice the field, deploy the field measurements prior to actually going to the field, a kind of simulator, if you will, that allows crews to learn how to lay out plots and do the calculations before going into the field. But because the data management system has the handheld app, it allows the learners to go into the field and see how they're doing by tying back to the server. And so when plots are measured wrong or the sizes are inappropriately triangulated in the field, they can actually see the maps that they've been creating. They can see the data that's going in, and this instructor with them in the field can give them real-time instruction and improvements and corrections. Lastly, because it's not enough to have tools for the specialist. We need to have tools and outreach capacity to communities and lay citizens and the whole of a society. So we've developed a communications and engagement platform that has tools for outreach and engagement, both for public consumption and for professional use. So let me walk through the tools by way of some view graph presentations of the platforms that we're developing. So first we have a new method for remote sensing. This shows the work we deployed for deforestation, degradation, and forest cover mapping in the country of Malawi. We use something called the FC tool. The FC tool is based on a forest fractional cover that gives continuous fields estimation of forest. So it's not just a simple forest or non-forest map, but shows the density of the forest, and it actually shows trees and tree systems outside the forest estate in the rural landscape, as shown in these examples here. So by doing that, we can actually accurately measure the extent of forest within a forest reserve or a place that is a project. And you can see from this example in Malawi, in the Luwande Forest Reserve, that there are areas inside the reserve that are no longer forest. There are areas that are very dense forest, and there's degraded or low stature forest in between. And the green line shows the boundary of the reserve, and then the coloration in green is the density of the forest from low density zero forest tree cover to 100% cover. And then by measuring this density, and the density changes 2 points in time, then we get this picture right here, which shows how we've mapped the intensity of change from low intensity degradation, which is in the blues, and the middle colors is green, to the high density, significant degradation, significant loss of biomass, shaded in the oranges and reds all throughout the area. This allows the analyst to pinpoint where the change is occurring, align the deforestation and degradation activity data with the appropriate emission factors, which is the carbon stocks at the locations of change, and also target where interventions would be placed with communities that one would work with to try to reverse the degradation in those particular locations, and thus focus the application of resources as needs are assessed. So we launch right into the Forest Knowledge Management Platform. This one was developed for the government of India, and it's called the Forest Data Management System that supports the forest carbon mapping for India. This is the opening page. It has a secure login that provides a specified workspace for a group or individual user, and this allows for the system to be cloud-based and distributed, but secure. The first piece, or one of the pieces, is a basic simple mapping tool. It's not meant to replace GIS. We expect that if someone or an agency wanted to do GIS, they would use the GIS. This, however, allows you to lay out in a hierarchical manner the project boundaries, the what we call parcel boundaries, which could be forest strata, or it could be legal parcels of ownership, and then the individual plots. So it's a three-layer hierarchy: project, parcel, and plot, and it allows some interactive mapping of the project boundary as shown here in green, the locations of the plot. I'll show you later how the plot locations and numbers are determined, and then also allows you to stratify the area according to forest type or whatever stratification scheme you want, which is required of the IPCC by the IPCC. You can take any of these polygons and upload them as shapefiles from your GIS system, or as coordinate comma delimited files from your GIS system as well. Has an editing function where you can edit and change the locations. You also have a tool that allows managers to lay out the locations of plots, send the teams to the field, and when they report back on the precise locations, the system can get updated with the precise locations of the plots. For every plot, we have a measuring tool that allows the data to be from the field to be uploaded either by paper form, spreadsheet, or through the handheld app that was deployed into the field. And each of the plots is associated with a strata or a parcel, and this is a relational system that allows you to organize all the plot level data right down to the individual tree level, which is perfect for managing the data, but also for verification by a third party who can do the verification online. And we do accommodate, we do focus on tier 3 level data, but we also can accommodate tier 1 and tier 2 generalized data. And this just shows the opening page of one of these, this part of the measuring tool. We also have embedded a sample design tool that allows you to specify the required accuracy, some a priori information on your population characteristics in terms of variance, and what it will do is calculate according to IPCC methods the number of plots per strata, and also then another tool here allows the GIS function to do a random location of those plots either through a systematic sampling scheme or a random stratified sampling scheme that you choose. This just shows the result of one sample tool, and you can see the other tab is the plot mapping tool. We also include a shareable, updatable, dynamic library for allometric equations. We have many of the basic allometric equations from around the world embedded, and we have a way to add more allometric equations either by updating specific equations or by actually creating your own equation. This system has the capability of parsing and reading any equation that you've developed, even though there's some generalized forms for most allometric equations. If you have a different form of equation, you can put it in, and then it allows you to share or not share that equation with the world community or with a specific community. So this allows us to do a lot of crowdsourcing, but at the same time, if you're a agency that needs to keep most of your information very buttoned up, you can do that as well. So that shows this on this page. And then for the field deployment of these tools, we have a handheld device called the mForest app. It links the advanced optical remote sensing protocols and methods to the DMS, the data management system, through the server on one hand, but it also links the app through field inventory mobile apps for data being collected by professionals or community folks in the field, all linking into the data management system. Now, of course, do we need to provide for capacity building? And we focus on both in-service professionals and through formal education, developing a pipeline of learners in diploma programs. We found that there's great advantage to a distance learning approach, so we've developed a learning management system that allows content providers like teachers or professors or trainers to develop course material. This learning management system we've developed under USAID funding has already a basic course, 12-module course on everything from the basics of how the climate system works all the way to how you collect data and how you develop a project design document and develop the methods and protocols for the collection of data from remote sensing and from ground data measurements. This shows the screen from the learning management system. And this shows another screen from the learning management system that gives an idea of how we use multimedia layers of information and learning content from online lectures, readings that are available, and videos and multimedia. We find the distance learning approach to be very effective at getting information to large numbers of people over a large area. This example shows how there's both content management tools in here, so you can manage the content of the course and how it's presented, and also share it. So this just shows a slide that's popped up and a video that's popped up on the section of the course related to introductory material. These are the features of the learning management system that allows you to manipulate content, create, manipulate, manage content, and develop your course with wikis, surveys, quizzes, lesson plans, all kinds of objects that allow a teacher to tailor the course to the learner's needs. One of the things that we do is we link in the data management platform as a kind of simulated environment where learners go in through the learning management system, get access to the data management platform. There are sample data sheets in there of inventories that were collected in the field, and they can use those to simulate the deployment of a sample frame and a national forest inventory and get practice. And then they can go to the field and do training deployments of plots and inventories with the handheld app that allows them to get real-time feedback from the system as to how they're doing, and allows the learner back in the classroom, or the learner with the team class in the field, to give feedback. This is the page that shows the link to the workspace for the virtual laboratory that I'm talking about. It has data sets for the DMS, and then a linkage to online resources, the DMS with the user guide and that. So this constitutes a kind of a laboratory testbed environment inside the learning management system. And then lastly, we're working with our Indian partners through a company called Vertiver, which is a collaborator of our partner at IORA, headed by Chaya Banti. And Chaya has developed a number of tools and approaches that have been very effective at taking the science, really taking even this actionable science out of the science and getting it into public consumption. Let me just show you. So there are a number of tools and expertise on basic communications. This was a very successful campaign as a public-private partnership activity in India called Forest Our Life. Billboards in airports and all over the city of Delhi and in Bangalore and elsewhere were displaying art from artists that were commissioned from Bihar to inform the public. But there's also some more technical outreach and engagement for infographics and storytelling, or brochures and storytelling, as well as the design work, effective design work around the handheld apps. And actually the learning management system in the DMS is also done by the Vertiver design team, so that it's most appealing and most accessible by a large number of people. So that's the overview of this system, and we're very happy to talk more about this at another time.